Hi guys, in this series of videos we'll be looking at the four fundamental interactions, gravity, electromagnetism, the strong and weak nuclear forces, an interaction model, the weak nuclear force, beta decay, nucleon-neutrino interactions, electron capture and proton-electron collisions, and an exam style question.
So let's start by talking about the four fundamental interactions. What do we mean by that? Well, what we mean is that there are four fundamental forces in the universe, and that all other forces in the universe that we know of are really just applications of these. So a good example of this is friction. So we've got some block that we're pushing over some rough surface, and we'll say this D is our driving force, and we get this friction force, so this frictive force Fr, from pushing this block, and we say friction's a force. But really friction isn't a fundamental force. Friction is actually composed of things like electromagnetism. That's kind of really what's making friction happen. But it's far too complicated to actually think about friction in terms of electromagnetism, and so we kind of group its effects together in this thing called friction, which we use experimental values for to do calculations and to apply it in our everyday lives. But really, it's not itself a fundamental force, because there are only four, and as we're going to see later, we're going to go through a few of them here, really they are the fundamental things in the universe, and every other force we see, friction being one of them, is really just something that is sort of an easier way kind of grouping together the effects of these fundamental forces in something that's kind of easier for us to do. But it's not actually a fundamental force in itself. So what are these fundamental forces? Well, the first one is gravity. Now, all of these forces we're going to come back and look at in varying levels of detail over the course of the AS and the A2. So gravity is one of them. Now, this is the force between particles with mass. So for instance, here I've drawn this can be the sun and this can be the Earth. But obviously, there's the key thing is there I've said mass, so this could be anything, right? This could be, you know, an apple, and this could be an orange. There's no need for it to be these things. It's just, as we're going to see later, this is in fact, as we'll see in a moment, this is the weakest force. So this is the sun and the Earth. They both experience a gravitational force towards each other. Like I was saying, it's actually the weakest of the four. This is why I've chosen the sun and Earth to demonstrate it, because you simply wouldn't be able to measure this kind of force between an apple and an orange. The force would be so incredibly small. You need things on masses of the sun and the Earth for there to be a real huge effect, or the Earth and a satellite. For instance, the Earth and the moon, or the Earth and a satellite going around it. You need one of your masses to be huge. For instance, we feel the effect of the Earth through gravity, because the Earth is a huge mass, but we don't feel the effect of gravity towards each other. The mass between the force between a human and the Earth is quite large, but the force between a human and a human is very small because it's so weak. But it also has infinite range. For instance, we saw with the strong forces we'll talk about in a moment, it definitely didn't have infinite range, but gravity does.
Hey guys, to continue watching this video and unlock hundreds of other super concise and exam board specific A-level physics videos, just click the Snap Revise smiley face. Join me today, and together let's make A-level physics a walk in the park.